All right, question one. Solve the exponential equation by expressing each side of the power of the same base and then equating exponents. So 5 to the x equals 5 or 25. And so on this one, 5 to the x equals 25. So I think what's a number that has that 25? I guess what's a factor 25 that has the same base as 5? Or I'm going to make 25 with a base of 5. And so 5 to what exponent gives me 25 squared? So x equals 2. So the solution set is 2. Write that down. Okay. All right, next question. Sorry about that. A little slow this morning. 9 to the 2x minus 12 equals 6,561. So this has a base of 9. So I'm going to try to guess what that is. And so 9 to what power gives me that? So I'm going to try 9 to the 4th. Oh, that works. So that means that 2x minus 12 equals 4. Add 12, 2x equals 16. Divide by 2, x equals 8. So the solution set is 8. Okay. Let's go to the next one. All right, 16 to the x plus 1 equals 256 to the x minus 2. Okay, now this one might have a special issue. Let's see what 16 squared is. Oh, 256. So 16 to the x minus 1 equals 16 squared times x minus 2. Okay, so x minus 1 equals 2 times x minus 2. So I'll distribute. Then I'm going to subtract x. So I've got x, add 4, x equals 3. So the solution set is 3. Whoops. Uh-oh. I messed up. So 2x, subtract x, and then it's minus 4. Oh, goodness. So this is 16 squared. X plus 1. I copied the problem down wrong. I'm sorry. This would be 5. So I apologize about that. Copied the problem. I copied the problem down right, but I copied the next step wrong. So the solution set is 5. Number 4. Solve the exponential equation, express it in terms of natural logarithms or common logarithms, and then use a calculator to obtain a decimal approximation. So 10 to the power of x equals 3.94. And so what you do to bring the x down is you take the log of both sides. So you're going to do x times log of 10 equals log of 3.94. And then what I'm going to do now is I'm going to divide both sides by log of 10. So x equals log of 3.94 divided by log of 10. So that should be my first one. So I'm going to start with a fraction. Log of 3.94 divided by log 10. You could use ln if you want as well. Oh, log of 10 is 1. Well, okay, that's 1. So that's just 1. So it's just log of 3.94. I apologize about that. Because log of 10 is equal to 1, because I wasn't paying attention there, so log of 10 is 1, so x would just be log of 3.94. And then log of 3.94 is equal to, so I'm going to go to log 3.94, 0.5, how many decimal places we want? 2 decimal places, so 0.5 or 0.60. So 0.60. All right, question 5. Solve the exponential equation that express the terms in natural log. Okay, with the base e, I'm going to do the ln of both sides. I guess it doesn't technically matter, but I'm going to do the ln. So I'm going to do x ln of e equals ln of 3.96. ln and e cancel, so x is equal to ln of 3.96. Okay, so hopefully I got one right here. I'm not doing so great this morning. So we use ln when the base is e, the natural log. And then ln of 3.96 is equal to ln of 3.96, 1 point, how many decimal places? 2, 1.38. So 1.38 for that. Okay, next question. Solve the following exponential equation. So 2, we got base e, so I'm going to do the ln. But first off, I got to divide by 2. I want to get the e isolated, so I'm going to divide by 2 first. So e to the 7x equals 1006 divided by 2, which is 503. Whoops, goodness gracious. 503. Now I'm going to take the ln of both sides. So 7x ln e equals ln of 503. Okay, that cancels. And so now I'm going to divide by 7. Divide by 7. X equals ln of 503 divided by 7. Now, what is ln of 503 divided by 7? I'll do that in my calculator. I need to make this window smaller here. 503 divided by 7. How many decimal places? 2 again? 0.89. Make sure it's 2. Probably is 2. Two decimal places, okay. Didn't want them to change up on me. All right. Question 7. You've got to solve these exponential equation. So e to the 11x minus 5 minus 3 is equal to 19,060. So first thing I'm going to do is I'm going to add 3. So e to 11x minus 5 is equal to 19,063. Now I'm going to take the ln of both sides. So 11x minus 5 ln e is ln of 19,063. Okay, and now what I'm going to do is I'm going to rewrite this. I'm going to add 5. So 11x equals ln of 19,063 plus 5, and divide by 11, x equals ln of 19,063 plus 5 divided by 11. So ln of 19,063 plus 5 divided by 11. Okay, now I need to find what that approximates to. So I'm going to do ln of 19,063 plus 5 divided by 11. So I'm going to put parentheses ln of 19,063 plus 5 divided by 11. So 1.35. Okay, let's go to the next question. All right, so now this one's a mess. This one's going to take a little bit of room. On 8, I've got to find, I'm going to use logs here with the number bases. So I've got 7 to the power of 2x plus 3 equals 5 to the power of x minus 4. So I'm going to take the log of both sides. So 2x plus 3 times log of 7 equals x minus 4 times log of 5. Then I'm going to distribute. So 2x log 7 plus 3 log 7 equals x log 5 minus 4 log 5. Okay, now I want the x's on the same side. So I'm going to move the x over here. Minus x log 5. And I'm going to move the numbers over here. Anything with just minus 3 log 7. So I'm going to have 2x log 7 minus x log 5 equals negative 4 log 5 minus 3 log 7. These two have a factor of x. I'm going to factor out x. So I'm going to have 2 log 7 minus log 5 equals negative 4 log 5 minus 3 log 7. And I'm going to divide both sides by 2 log 7 minus log 5. 2 log 7 minus log 5. And so x equals negative 4 log 5 minus 3 log 7 divided by 2 log 7 minus log 5. So that should be my answer. Okay, this is a mess here. So I'm going to start with the division sign there. So negative 4 log 5, backspace, 5 minus 3 log 7 divided by 2 log 7 minus log 5. Now, find out that approximation. I'm going to write this down here. So negative 4 log 5 minus 3 log 7 divided by 2 log 7 minus log 5. That approximates to, oh, you guys do your seats here. I'm wondering if the alpha, if this will work, if I do it a fraction like this. I don't know if it's easier. I don't know if it's going to leave it like this because it's not going to be, because this is not going to be a rational number solution. It might be easier if you did the fraction there. Okay, so yeah, do that. Do the alpha y equals there, negative 5.38. That makes that a lot easier to enter. So negative 5.38. All right, let's go to question 9. So question 9, you got to be careful too on this, and then use a calculator to obtain the decimal column. Okay, so e to the 2x minus 8e to the x plus 7, okay, equals 0. So you need two numbers. You're going to factor this. You need to multiply to 7 and add to negative 8. So you're going to multiply the 7 and add to negative 8. So negative 7 and negative 1 8, or multiplies the negative, or 7, positive 7. Goodness gracious, making a mockery of this. Negative 7 times negative 1 is 7. Negative 7 plus negative 1 is negative 8. And so we're going to do e to the x minus 7, and then e to the x minus 1 equals 0. Okay? Next thing, you're going to set each of these equal to 0. So e to the x minus 7 equals 0, and then e to the x minus 1 equals 0. To solve, so add 7, e to the x equals 7. And you'll take the ln of both sides, so x ln of e equals ln of 7. That cancels, so x equals ln of 7. Okay, here we're going to add 1, e to the x equals 1. And you take the ln of both sides. ln of 1 is 0, by the way. So ln of 1, I can prove it to you. ln of 1 is 0, and that's going to be what they expect you to know. So x equals 0. It's because ln of 1. I'm going to write that down. ln of 1 equals 0, so x equals 0. So the solution set in terms of logarithms would be ln of 7 comma 0. Let me submit. Frozen. All right, so I'm going to write that down. ln of 7 comma 0. And then the solution set, ln of 7 is equal to, so ln of 7 is 1.95, and then you also have 0, so 1.95 and 0. So 1.95 and 0. All right. Let's go to the next question. My computer will let me. 10. Solve the following logarithmic equation. Be sure to reject any values of x that are not the domain. You have to keep that in mind for people like me who go too fast and don't pay attention. Okay. So what you're going to do on this one is you're going to exponentiate this. So you're going to start with this base, rewrite this in exponential form. So that exponent equals x. So 5 to the third equals x. What's 5 to the third? Well, 125. Now 125 is in the domain. It's not, wouldn't make that negative. So 125 is the solution set. So the solution set is 125. Okay. Now let's go to the next one. Log base 2 of x plus 3 equals 2. So I'm going to exponentiate this. So 2 to the second power equals x plus 3. 2 squared is 4. So then I'm going to subtract 3. X equals 1. Now, if I plugged in 1 into that, it's going to be in the solution set. It wouldn't make it negative. And so the solution set is 1. Okay. Now let's do the next one here. 12, I've got 5 ln of 7x is equal to 15. So the first thing I'm going to do, and they're wanting the exact solution, so I got to be careful here. So divide by 5. So ln of 7x is equal to 3. Now the base of ln is e, so I'm going to exponentiate this. E to the third is equal to 7x. And then I'm going to divide by 7. And so this x is equal to e to the third divided by 7. So the solution set is e to the third divided by 7. It's just a part, yeah, it's a 2 parts, because they're going to want me to simplify this on the second part. So e to the power of 3 divided by 7. All right, so the decimal, e to the third divided by 7 is equal to the second ln, and then divided by 7. 2.87. Going 2 decimal places still? Yes. So there's your number 12. There we go. All right, let's look at 13. So 13, I'll try to fit it down here. I'm probably going to, well, let's go back up here at the top. So 13, I have log base 9 of x plus log base 9 of 8x minus 1 equals 1. And so I'm going to condense the logarithms first. So I'm going to do log base 9. They're adding, you multiply, so times 8x minus 1 equals 1. So log base 9 of 8x squared minus x equals 1. Okay? So the next thing I'm going to do, I'm going to exponentiate this. So I'm going to do 9 to the first equals this. So I'm going to have 9 to the first equals 8x squared minus x. Okay, so 8x squared minus x is equal to 9. I subtract 9, 8x squared minus x minus 9 is equal to 0. Okay, so now I'm going to do factoring. Try to factor here, see if that's factorable. And so let's see. Let's try, well, I could do 8x and x. They're going to be different signs. Well, if I did ax minus 9 and x plus 1, that'd be negative 9x. That'd be 8x. And that would add to 1x. So then I'm going to set each of these equal to 0. So 8x minus 9 equal to 0. X plus 1 equal to 0. And so subtract 1, x equals negative 1. Add 9, 8x equals 9. Divide by 8. X equals 9/8. Okay. Now the problem here is if I plugged in negative 1 into here, it would make that to where the log wouldn't work. So I'm going to throw out negative 1, and it's just going to be 9/8. Okay. So it's 9/8 here. So 9/8. All right. 14. So you'll often have to throw out an answer on some of these. Log base 4 of x plus 6 plus log base 4 of x plus 3 equals 1. So log base 4 and then x plus 6 times x plus 3 equals 1. So then I'm going to exponentiate this. So 4 to the first equals x plus 6 times x plus 3. Okay, and so I'm going to distribute here. I'm going to rewrite this over here. So x squared plus 3x plus 6x plus 18 equals 4. I'm going to subtract 4, and I'm going to get these together too. So x squared plus 9x plus 14 equals 0. So now we got a little easier factoring one here. So what multiplies to 14 adds to 9? About 7 and 2. Uh-oh, we might have some issues here. So then x plus 7 equals 0. X plus 2 equals 0. Subtract 7, x equals negative 7. Subtract 2, x equals negative 2. Now, you could have a negative answer, but the problem is If I plugged in -2 into this, it would still be positive. If I plug a -2 into that, it'd still be positive. If I plug a -7 into this, it'd be negative on both of those. So I'm going to throw out the -7, and I'm going to keep the -2. So I can have a negative answer, just can't make the log negative. So it's going to be -2. Okay. Let's go to the next one. 15. We're going to be doing some dividing here because it's subtracting. So I've got log base 3 of x plus 23 minus log base 3 of x minus 3 equal to 3. And so I'm going to make it a 1 log, condense it. I'm going to do x plus 23 divided by x minus 3, and that's equal to 3. So the next step here is I'm going to exponentiate it. So 3 to the third equals x plus 23 divided by x minus 3. So 27 equals x plus 23 divided by x minus 3. Multiply both sides by x minus 3. So x plus 23 is equal to 27x, okay, minus 81. Okay. Now I'm going to get x by itself, subtract x, so 26x, add 81, 23 plus 81 is 104, divide by 26, x equals 4. Now 4 would be fine here because there wouldn't make any of those negatives, so it would be, solution set would be 4 here. All right, down to page 2 now. Okay, 16, solve the logarithmic equation. Be sure to reject any values of x. Okay, so I've got log, this one's not too bad. Log of x plus 5 is equal to log of x plus log of 5. I'm going to condense these over here first. It's going to be log of 5x. And then the logs cancel. So x plus 5 equals 5x. Subtract x, 5 equals 4x. Divide by 4, x equals 5/4. And if I plugged in 5/4 of those, it would all work. Like it would wouldn't be negative, so it would be 5/4. All right, solve the logarithmic equation. So I've got log of 3x minus 7 equals log of x plus 2 plus log of 4. So I'm going to condense these.
Students, the library is closed this morning. Teachers, don't forget you have chicken minis and coffee in there.
All right, so it would be 4 times x plus 2. So log of 3x plus 7 is equal to log of 4x plus 8. And then I will cancel out the logs. So 3x plus 7 is equal to 4x plus 8. Subtract 3x. I got x. Subtract 8. I got -1. So x is equal to -1. But if I plug that back into there, 3 times -1 minus 7 is -10. So this is not going to work. And so there's going to be no solutions here. There is no solution. Okay. I should have shown that work on the other side, by the way. I apologize for not doing that. Just trying to fit all this in one paper. Oh, 18. Okay. Log of x plus 12 minus log of 2 is equal to log of 4x plus 3. So log, now I'm going to divide x plus 12 divided by 2 equals log of 4x plus 3. Okay, that can cancel those, x plus 12 divided by 2 is 4x plus 3. Multiply by 2, x plus 12 equals 8x plus 6. Okay, subtract x, 7x, subtract 6, 6. So divide by 7, x equals 6/7. Oh gosh, not in 10 for that. Now, if you plugged in 6/7 or 6/7, it's not going to cause any issues there. So my answer is 6/7. Whoops, they want me to do it without logarithms. Oh, do not solve for x. Well, how about I pay attention? Solve. Oh, it's a part, 2-part. So I wonder if they're wanting this x plus 12 divided by 2 equals 4x plus 3. Okay. I'm sorry, so I should pay attention. That's one of your answers, and then 6/7 is your other one. Okay, let's go look at 19. See how many questions I have left. I'm pacing myself on this paper here. All right, 19. We're just going to solve this one. So log of x plus log of x minus 2 is equal to log of 15. So then I'm going to multiply and drop the logs. So x squared minus 2x. Subtract 15. X squared minus 2x minus 15 is equal to 0. So we got to find what multiplies negative 15 and adds negative 2. What about 5 and 3? Okay, so negative 5 and 3. So it'd be x minus 5 equals 0. X plus 3 equals 0. Add 5, x equals 5. Subtract 3, x equals negative 3. Negative 3 we're going to have to throw out. 5 we can keep. So the solution set's 5. Hopefully that shows up when I scan it. It's a little low. Okay. 20. So I've got ln of x minus 8 plus ln of x plus 1 equals ln of x minus 24. So I've got ln of x minus 8 times x plus 1 equals ln of x minus 24. Ln's can drop, so it'd be x squared plus x minus 8x minus 8, x minus 24. Subtract x, add 24, add 24. So it's x squared minus 8x plus 16 equals 0. So this would be what multiplies to 16 and adds negative 8. Be x minus 4, And so that would be x minus 4 equal to 0. Add 4, x equals 4. Now the problem is, if I plugged in 4 into this, 4 minus 8 is negative 4. And so that's going to be, so 4 won't work. So this is going to be no solution. Because if I plugged in 4, it'd make the log negative, so there is no solution. There is no solution. All right. 21. The formula A equals 18.5 e to the 0.1711 t models the population after T years after 2000. So what was the population in the state of 2000? So A would be 18.5 E 0.1711 times 0. So for A, T equals 0. For A, I should have wrote that first. And this is going to make this the 0 power, and it's just going to cancel. It'll be 1, so it'll be 18.5. Okay. When does the population reach 26.6 million? So A is going to equal 26.6. 26.6 equals 18.5 E, the 0.1711 T. So first thing I'm going to do is I'm going to divide by 18.5, divide by 18.5. So 26.6 divided by 18.5, 1.438 is equal to E, the 0.1711 T. Now I'm going to take the ln of both sides, so ln of 1.438. So you get a 0.1711 T ln E, that just cancels. And I'll divide by 0.1711. Okay, and so I'll have, they just said the year, nearest year. All right, so it'll be ln of this divided by 0.1711. T equals 2.12, so around 2 years. So that's going to be starting in 2000, so it'll be 2000 plus 2, it'll be 2002. Okay, question 22 eventually will show up. All right, the formula A, I'm going to write that down. R divided by N, the power of N T, describes the cumulative value of the sum of money and pre-principal after T years. And so complete the savings after N compounding sessions per year. Okay, so the amount invested is 12,000. Okay, so invested 12,000. So that's going to be P. Number of compounding periods. Periods is 4. That is N. The rate is 6.25%, which is 0.0625, which is R. And then the accumulated amount is 23,000, and that's going to be A. So we're going to solve for T. So I'm going to do 23,000 equals 12,000, 1 plus 0.0625 divided by N, which is 4, the power of 4T. So first thing, I'm going to simplify everything in the parentheses here. So 1 plus 0.0625 divided by 4. So it'd be 1.016, the 4T. Now I divide by 12,000. 12,000. So 23,000 divided by 12,000. is 1.92. That's 1.016 to the power of 4t. Now I'm going to take the log of both sides. So log of 1.92 is equal to 4t log of 1.016. Now what I could do here is I could divide both sides by 4 log of 1.016. When I type this in my calculator, I'll just put it all over that. So I'm going to do alpha nd here, log 1.92 divided by 4 log of 1.016. It's a 10.27 years. So don't round the final answer 1 decimal place, so 10.3 years. So 10.3 goes here. Oops, didn't mean to. Maybe I rounded. Let's see. All right, on this one, I had to go further in the calculator on the decimals. I went exact. That's frustrating. And so when using exact, I got 10.5 years. So I know that's frustrating. So I use the exact values. All right, so question 23 asks, I've got the function p of x equals 75 minus 30 log base 2 of x. Okay, so we're given a function and it has important features about the graph, and we want to know how many days till half the students recalled. So you're going to put 50 in for p of x. And you're going to solve this. So subtract 75. Negative 25 equals negative 30. Log base 2 of x. Divide by negative 30. Divide by negative 30. So 0.83 repeating equals log base 2 of x. Then we're going to exponentiate. So 2 to the power of 0.83 repeating equals x. So 2 to the exponent of this. So x equals, how many decimal places are they wanting here? 1 decimal place, so 1.8. How many days? So 1.8. So 1.8, you look on the graph, when it gets 50, it's around 1.8.